In this lesson, you will learn to solve quadratic equations using the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. This method of solving works best for equations in standard form, actually all of those types of equations. For equations in vertex form, this method cannot be used. You should have previously worked with the discriminant, b squared minus 4ac. Based on the value of the discriminant, we can determine the number and type of solutions, and we also can determine, if we were to graph it, how many x-intercepts the graph would have. By using the quadratic formula, you're actually going to be able to determine those actual solutions. Let's look at our first example. The height in feet of a diver above the water can be modeled by, and we have our quadratic equation, where t is the time in seconds after the diver jumps off a platform. Find the time it takes for the diver to reach the water. So we have a picture to help us identify or visualize this problem. If we have our quadratic, we see that it is that U shape that we have with our parabolas. Because it is asking for the time that it takes the diver to reach the water, so here reaching the water, that would have a height of 0. So that's why we can take h of t and substitute a 0 to be able to solve for the time that it would take for the diver to reach that height. So let's do that now. We're going to start with naming our a, which is negative 16, b equals 8, and c equals 8. And yes, even though this variable is t, it works just like equations in standard form with the variable x. The a is in front of the t squared, b is in front of t, and then c is the constant on its own. Well, let's start with the discriminant. B squared minus 4 times a times c. So plugging in those values for the discriminant. We can use our calculator to help us correctly use order of operations to solve. So b squared minus 4 times a times c. That gives us 576. So let's refer back up to our chart. Because the value of our discriminant is positive, we're going to have two real solutions. So I know that may seem weird, especially with this situation. We're finding the time it takes for our diver to reach the water. We actually will not need both of these solutions. Although we will have two real solutions, we'll need to identify which of the solutions is actually our answer for the time that the diver reaches the water. So we'll talk through that when we get there. So this being a positive value tells us we have two real solutions. So let's find those now with the quadratic formula. X equals, or just t, since that's the variable we're working with in this problem, negative b plus or minus the square root. Because we've just evaluated the discriminant, that was that b squared minus 4ac, we can just substitute in that value, 576, rather than reworking b squared minus 4ac. I recommend just plugging in that value of the discriminant there. All over 2a, and a is negative 16. So now we will solve from here. We will multiply, take the square root, and multiply. So you might want to make a note here to the side. That's what we're doing, is multiplying, taking the square root, and multiplying. Those are the next things we can do in our work. So negative times positive is a negative 8. Plus or minus, we'll need to take the square root of 576. I hope that's a perfect square. It is. So square root of 576 gives us 24 over 2 times negative 16 gives us a negative 32. So once you set up the quadratic formula, begin just simplifying. So we've done that so far as multiplying, taking the square root and multiplying. So now our next step is to do this addition and subtraction. In order to do so, we'll need to make two equations. So negative 8 plus 24 divided by negative 32, and negative 8 minus 24 divided by negative 32. Separating this out, making two equations using that plus or minus, because that's the next step that we are at. I do recommend here that we just type them in the calculator using alpha y equals. We could continue solving on our own with order of operation, but I often find that students have error in their work, and our calculator can help you do that correctly. So alpha y equals, let's type this in. We have negative 8 plus 24. Don't forget your denominator of dividing by negative 32. So one of our solutions is negative 1/2, or if you prefer, you can hit math, which is under the green alpha key, and let it give you the decimal, either one, fraction or decimal. We also need to do, again, alpha y equals negative 8 minus 24, and again, don't forget your denominator, divide by negative 32. So our two solutions are either negative 1/2 and 1, or you can do the decimal. Negative 1/2 and 1. So this is where I was talking about, yes, our discriminant, since our discriminant was positive, it told us we would get two real solutions, and that's what we have done. However, for this situation, since we're finding the time that it takes the diver to reach the water, there's only one solution that really makes sense for this situation. Negative 1/2 or 0.5 is actually what we call an extraneous solution because time cannot equal a negative. So we will say the diver will reach the water at 1 second. And we know it is at 1 second because back in our situation, it told us time is in seconds. So this is how we can use the quadratic formula to solve for those solutions. Let's look at example number 2. Here we have our equation. Before we can ever name A, B, and C, we need to make sure that it's in standard form, meaning all variables are on the same side and the equation is set equal to 0. Otherwise, we cannot truly name our A, B, and C. Well, I can see that I have one term here on the right, or I have two terms here on the left. And you can move those variables either way in order to get it to standard form. My recommendation is, 1, do as little as work as possible, and 2, try to keep your x squared term positive. So here, because there's only one thing to move, I want to do as little work as possible. I can move that one term, and if I moved it, it would make it become positive. That's what I'm going to do. So adding 2x squared to both sides, we actually will not be able to combine that with anything because we don't have a like term. We will just put them in the correct order, ax squared, bx, and then c. So that 2x squared will go first, and then the plus 3x, that's going to serve as our bx term. And then finally, the minus 5 for our c. And that truly does equal 0 because these terms cancel. If you prefer to have your equal 0 on the front of your problem on the left side, feel free to write it first. But what is important is that we have all three terms, A, B, and C, in order set equal to 0 before we can go on and actually name our A, B, and C. A equals 2, B equals 3, and C equals negative 5. So we can use those to find our discriminant. So we have b squared minus 4 times a times c. We can find the value of that discriminant using our calculator. So 3 squared minus 4 times a times c. That gives us 49. So let's stop and think again for a moment, referring back to our chart at the beginning. Because that is a positive discriminant, we can have two real solutions. And our quadratic formula will help us find those solutions. So let's plug that in. X equals negative b, our b earlier we said was 3. And it might actually help if you highlight or box those in, put stars around it or something, because once we name those A, B, and C's and we move on, sometimes it is hard to look back up and pick up the correct number. So put a box or star or highlight around them so it helps you identify those correctly. So negative b plus or minus the square root b squared minus 4ac. We just found the discriminant and we know that it equals 49. All over 2 times a, and our a is a 2. So now we'll begin working out this quadratic formula. First, we need to multiply. Negative times a positive is a negative. Plus or minus, take the square root. Square root of 49 is 7. And multiply. 2 times 2 is 4. So at this step, all we're doing is simplifying by multiplying, taking the square root, and multiplying. Well, because our next step is doing the plus or minus sign, we're going to separate out and do plus and minus. So negative 3 plus 7, divide that by 4, and negative 3 minus 7, divide by 4. At this point, I do actually recommend using your calculator so that you can set that up in alpha y equals. So alpha y equals, and let the calculator correctly identify that solution. So negative 3 plus 7. Don't forget about your denominator. I do find some students leaving that off, and it causes you to miss the problem. So negative 3 plus 7, we want to have it over 4. And then we'll do another alpha y equals negative 3 minus 7, and still divide by 4. So we get our two solutions, 1 and negative 5 halves. Again, feel free with that fraction if you want to hit math decimal, which is option 2. It will change that fraction to a decimal. So either answer is fine as long as the decimal terminates. So 0.5, because it stops and does not repeat, you can use the decimal. But if it's a repeating decimal, you have to use the fraction. Let's now finish by writing our answers in set notation. We do put those least to greatest. So negative 5 halves, or the decimal would be fine, and then 1. By the way, I do want to mention when you do your plus or minus, if you want to do the minus first, that way they're already in least to greatest order, that is something that might help you get your set notation correct. Let's look now at example number 3. First, we need to get the equation set equal to 0 and written in standard form. We do see that this equation is already set equal to 0, but be very careful it's not in standard form until we have our ax squared, then the bx, and finally the c. So that means we need to reorder these. Ax squared will go first, then our bx, and then finally the c. So rewriting those, x squared minus 6x minus 7 equals 0. Let's name our a, b, and c, being very careful since we have negatives in this problem that we include those when we name our coefficients. Since I know I'm going to need to refer back to these often, I'm going to go ahead and put a box around them so that as I work through my problem, I can continue to refer back to them as needed. Let's do our discriminant. So b squared minus 4ac, and that's a -7. Always being careful that you plugged in exactly what you say your a, b, and c equals. Here, it's especially important that you square the negative, including those parentheses. So let's do that in our calculator. -6 squared minus 4 times 1 times -7. We get that our discriminant equals 64. And as we've already saw in the last two examples, because that is positive, we will have two real solutions. Let's solve the quadratic equation so that we can see those solutions. So negative b, plugging in that -6, plus or minus the square root. We know that b squared minus 4ac equals 64. We just solved that all over 2a. We're ready to multiply. Take the square root and multiply. So we get positive 6 plus or minus the square root of 64 is 8 all over 2. Because we have our plus or minus sign, we need to make our two equations. 6 plus 8, we're going to divide that by 2, and 6 minus 8, we're going to divide that by 2. So we get, using alpha y equals 6 plus 8, and when you divide that by 2, that gives us a 7. And again, alpha y equals 6 minus 8, and divide that by 2, that gives us a -1. So our solutions, 7 and -1, when we write them in our set notation, least to greatest, we have our solutions for our quadratic. I do want to mention with the calculator, notice the only things I'm typing in. I do not want you to type in the entire quadratic formula. We type in the discriminant and let the calculator help us with that order of operation. And we type in the final steps. If you need the calculator's help with actually taking the square root or the multiplication, that is fine. But never have I shown you typing the entire equation into your calculator all at once. I just find that too many students make errors on simple things, and it causes you to have to redo your work anyway. So just take it a step at a time, letting the calculator help you along the way. Let's do one final example. Number 4. We have 5x squared minus 28x plus 62 equals 12x minus 18. Well, notice this one is not in standard form. Even though, yes, it looks like the left-hand side is in the correct ABC order, it's not set equal to 0, so we need to do that first before we can truly name our A, B, and C. So we'll start with subtracting 12x, lining it up with its like term, because we will be able to combine those, and adding 18, again, lining it up with its like term. So we get 5x squared. When we combine -28 minus 12, we get -40. And then 62 plus 18, we get +80. This right-hand side truly cancels and makes it set equal to 0. I do recommend that you stop and check your work, because if you solve for the standard form incorrectly, I hope you realize how that can really affect your work beyond that. So take a break and make sure that you really have truly solved and gotten the correct standard form before you move on. I'm noticing I've left off my x. Let's name our A, B, and C now. A equals 5, B equals -40, and C equals 80. We'll use those numbers in our discriminant formula so we can determine how many solutions we would find. So b squared minus 4 times a times c Using our calculator, we can help see what that value of the discriminant would equal. So negative 40 squared minus 4 times 5 times 80. All of that equals 0. So again, referring back to our chart from the beginning, since we've not seen this yet, if our value of our discriminant is 0, we're only going to have one real solution. So let's finish that quadratic formula so we can find that solution. X equals negative, let's box in our ABCs so we make sure we're using the right numbers. So negative b plus or minus the square root, we found that discriminant to be 0, all over 2a, so 2 times 5. So this is why we get one solution. We're about to do our multiplication, square root, and multiplication. But let's talk about this square root of 0. It's going to equal 0. So let's go ahead and get to that step. Positive 40 plus or minus 0 over 10. Well, if I added 0 to 40, or if I subtract 0 from 40, it's the same value. So we actually no longer need that plus or minus 0. We can leave it off. So there's why we are getting just one solution. Feel free to still write two equations if you need. So if you still need to write 40 plus 0 divided by 10, 40 minus 0 divided by 10, and actually find it in that manner, just as you always have, you're going to see that you're just going to get one solution. Just as we have here, 40 divided by 10 gives us 4. That is our solution to this equation. So no matter if you add 0 or subtract 0, that numerator isn't going to change. And that's why our solution, we just have one solution. So in set notation, you'll just write one of those 4s. So even if you choose to do it this way and show 4 and 4 with the two separate equations, that's still just the same number, and we write it just one time. I do encourage you to memorize your formula. There's a lot of fun songs that you can help learn those formulas with. So memorize this formula to help you improve or help you do your best at solving.